Okay, good afternoon, everyone. Thanks for your coming. So today, this one is a Huawei small session, so we'd like to introduce ourselves first. My name is Fred, and I'm leading the Huawei OpenStack upstream team. Just to introduce that, we have two teams. One is the engineering team to productize the OpenStack and providing open cloud service and OpenStack distro as well. And I'm leading the team who is working in OpenStack Foundation. So this team is to connecting the open source and the customer. You?
Hi, my name is Dims. I've been working on OpenStack upstream for a while. Recently joined Huawei, and those are my two kids.
Okay. Today, the agenda will be including actually 4 parts. First two will introduce Huawei's journey on OpenStack and how Huawei develops products. And the the third and the fourth will be, as mentioned, the interoperability challenge we are facing and the activities we are working on. And we hope we can more and more contributors can join us to work together to make the ecosystem better. So I think Huawei is well known in telecom industry, and as well as recently Huawei is well known as mobile devices. Like we have many mobile phones, but as now here we are talking about OpenStack, I would like to introduce Huawei as Huawei is the platinum member of OpenStack Foundation. From 2012, next please. From 2012, Huawei started to use OpenStack and joined the Openstack Foundation. And in 2013, as one of the first China companies, we joined the Huawei OpenStack Gold member. And in 2015, as the first batch of the customers who are using OpenStack, we passed the OpenStack Power, the difficult certification. And this proves that Huawei is compliant with all the OpenStack releases. And in beginning 2016, Annie Lai from Huawei was elected as one of the board directors, and which is one of the 8 gold member director. And beginning this year, we joined the Huawei, joined the platinum member. And as a China company, actually at the beginning, it's very difficult for us to contribute technologies in OpenStack Foundation because of the first most of the China companies were quite new in open source area, and also because of the language issues and the culture issues and the time difference issues. So you can see at the beginning, like the Havana Ice releases, we contribute quite little. But recently we have grown so much, and in Okata and Pike, for example, regarding the completed blueprints, which is most important and difficult to work in OpenStack Foundation, we have ranked the #1 or #2. So this is our progress. And also, we are not only considering the blueprint, but also we faced many bugs during our usage. And also review is quite important for us to understand how OpenStack is designed and the coding. And also, as a result, lines of code and the commits are growing. When we talk about the project Huawei is participating in, we can find that, okay, this slide is the latest categorized of the OpenStack Foundation. We can see Huawei, the gray part is what Huawei joined and worked in, and the yellow part is what Huawei initiated. We can see for example, in the compute domain, we were working in most of all of the projects, and besides, we created the Cyborg, which is to manage the accelerators. And the Cyborg is working together with Nova as well, so that the users know what kind of the hardware and software is under that. And before, the bare metal services is provided by Nova and Ironic, and there is no dedicated service or projects to work on bare metal. So we created Morgan together with other vendors like Intel. And so these two projects are quite hot now, and the Cyborg just became one of the official projects in Openstack, and the Morgan will be discussed on Wednesday. So if you are interested in this project, please go to the forum, which is scheduled on Monday morning. And in storage area, we created a cover project, which is to back up the data. And on networking, we have many new projects like Dragonflow is to have a better implementation. And Query is to bridging the network between OpenStack and containers. And TreeCircle is the project is to solve the issues crossing clouds and OpenStacks. Okay. Besides the technology contribution, Huawei is also very active in socializing OpenStack. Like in China, we have one of the volunteers, we have organized 2 OpenStack Days China, and each of them, there are more than 2,000 people, so which is quite large. And also we have hosted 6 bug smashes events and have solved more than 600 bugs, which help OpenStack more mature. And the next one, the 7th OpenStack bug smash Queens will come in end of November, which will be in Wuhan. And if you are interested, please join either in person or online, so to take care of the bugs we are fixing. And we have many organized many meetups to talk about OpenStack projects, not only in China but also in US, in Europe. Okay, next part we will talk about what Huawei did on clouds. So Huawei as I introduced Huawei as a telco industry vendors before, so we have many customers in carrier area. And also, Huawei is providing public cloud now. So actually, Huawei provides not only public cloud, but also private cloud and NFVI infrastructure to customers. So you can see at the bottom, there are server storage, networking infrastructure. And upon that, we have FusionSphere, which is based on OpenStack. And then we provide the rich services, including IaaS and PaaS. And then we are facing different scenarios like a high performance computing area, so many clouds. And our customers, it's quite rich, including carrier, safe city, and extra. As a customer-oriented vendors, so we have many discussions and insight from customer point of view. So we believe that most of the enterprise need to move the IT system to the cloud. So some of the customers need to move the clouds to build their own public cloud. We call it the private cloud. And some of the customers need to move their services or applications to public cloud. And also some of the customers need to move between public and the private clouds. For example, if they need more devices or infrastructure just for a short time, from cost point of view, it's good to extend to public cloud for a short time. This is one of the very popular cases. So that's why we use OpenStack, because OpenStack can support all the different scenarios, and they have unified API and architecture. So this is a very, very important benefit from us. Okay. Please.
Next, I wanted to talk about the interoperability challenge that we are facing. So as it's very clear, we have many clouds, and we have a combination of private clouds and public clouds. And there are so many combinations of services and components that are running in these clouds. So what are the issues that we see when we take this in front of our customers, and what are the challenges that we face when we go to our customers? So just before we get into that, I wanted to share a little bit about what is currently being done from the OpenStack Foundation side for interoperability testing. And then I'll walk through what more can be done. So the most important component for any interop testing in OpenStack is the Tempest test suite. Most of the projects in OpenStack have a test suite, and there is a bunch of things that are there in the Tempest repository as well. So those form the core of the interoperability testing. Now, based on those tests that are in Tempest, a subset of them are marked for different trademark licensing programs like the OpenStack Powered Platform, which is a combination of more than Glance, Neutron, Nova, and Cinder, and things like that. So that's the platform. The compute is just Nova and Keystone, and the object storage is just Swift and Keystone. But then all these combinations are just running tests that are specifically marked in the Tempest test suite. And this is not something that the OpenStack Foundation runs. It's not like OpenStack Foundation runs against your endpoint and then gives you a certificate. It's you run it yourself, and then you self-publish, essentially. So, and then there is one more category which is called OpenStack Compatible, which is slightly different in the sense that suppose you are a hardware vendor, or if you have a storage solution that that you wanted to tell your customers that, oh, I've tested this with OpenStack and it works fine, and this is something that can be used in any OpenStack environment. So that's the another category, which is called OpenStack Compatible. So these two are the official trademark programs and licensing programs, and you get a stamp. You can use the logo and things like that in your website and materials and things like that. So the other thing that we do is, like, there is new interoperability challenges that we come up with in different vendors participate. And for example, in Boston, there were like 20 vendors installing the same exact application. So that is another level of, okay, there's so many people working on this stuff, and they are trying to do the same thing, and it works. So that's the live interoperability challenge. And then there is new things that we're adding, which is for people who are using Heat, if they want to be sure that the Heat templates that they are working on in one cloud will work on the another cloud, then it's called the add-on program for orchestration, and the other one is for DNS, which is designate. Next one. Thank you. So, so those are the interoperability programs. Now, what happens in the real world? Real world, we have the OpenStack API right at the bottom, and we have so many toolkits. Some of them are from the OpenStack Foundation, some of them are from vendors, some of them are from general people in the community who want to work on a specific language, for example, like JClouds, that's a Java one. Shade, that's a Python-based one that is maintained by the OpenStack infra, because the OpenStack infra actually uses multiple clouds to run the CI/CD systems. Then there is Go for Cloud, which is the Go-based implementation, which ends up in a few, that's in turn used by some other projects. So what happens is you have a bunch of CLIs and SDKs, and all of them have varying levels of quality and support for the different OpenStack APIs. So even if you make OpenStack API the best, the tools that use the OpenStack API have to be brought up to make sure that they are up to par as well. And then if you go on to the next level, then there are SaltStack, Ansible, Juju, Charms, Terraform, Bosch, those kinds of things. And you can see, like, every layer you add, you're just adding more complexity, and more things are likely to fail. And so things need to be tested together. Things need to be, People need to try it out together, and when we come up with a new release of OpenStack, what should we do? We have to test the whole thing again because we don't know what might break. And then there is forward compatibility, backward compatibility. So this is the real world. This is what we face on a day-to-day basis. When we go to a customer site or when we talk to different people who are using OpenStack tools, they'll say, oh, I tried this worked, that didn't work, or this combination worked, that combination didn't work, and things like that. So that's becoming better on a day-to-day basis because all of us are doing a lot more testing, and we are going to come up with some more ideas here in the next slide. So the interoperability issues. Too many tools, different quality. Then there's provisioning layer, there is container layers. So we are one community here, and it is very difficult for just one community to deal with all these layers all over the place. Thank you. So what do we do? First, we start with the OpenStack API layer. We make sure that it works best. Then the next one is go to the next layer, and how do we make sure that we can talk to all the people who are working on SDKs, and how do we make sure that they have enough support to test the stuff that they are developing, not just against the latest dev stack or the OpenStack version from master, but also the older versions. Then how do we build the partnerships between other communities, for example, the Kubernetes community or Gopher Cloud community? How do we build relationships and partnerships with the other communities to make sure that things don't break in the future? It's not like a one-time thing. Okay, I wrote some code, I'm sending it out, and everything is fine. It'll never break. That's not the case. We have to continuously test and make sure that things are working all the time. Again, I'm going to repeat myself, which is not just the newer version, but also the older versions too. So next one. So what are we proposing here? Huawei, along with Intel and the foundation and a few other people, we are starting a new thing called the Open Lab. The Open Lab is for testing, reporting, development of all the tools and applications that people generally use. Whether it is Kubernetes, Terraform, Gopher Cloud, JClouds, all these things needs to be tested, and some of them needs to be tested together as well. So that's what we want to do in Open Lab. So here we want to people to be able to replicate what they have tested and make sure that it doesn't break over time. And we want to add hybrid and multi-cloud testing as well, in addition to testing against single clouds. Next one, please. Why do we need? I think I've made it very clear already. So it needs to be an ecosystem solution. It's not just our community problem. We need to buy in from other communities as well. And we need a common place where we can do this testing and repeat this testing. And it's not just OpenStack APIs, but other APIs we'll need to work with other APIs as well, because some other APIs essentially turn around and call OpenStack APIs, and so there's translation layers and whatnot. So that's the other thing. Right. So consumers of clouds need reliable tools and applications, and they need a place where they can go and say, okay, what is the version of things that work together that I can easily go try, so that I don't have to go through all the testing that you guys had to go through to select this set of versions. So they need it for reference. So how does this work? We are still trying to figure out the governance model for this Open Lab, but we will follow most of the things that is already there in our community, like the 4 opens. We'll make sure that the people who are doing the work get to decide what needs to be done. And so it'll loosely follow what we do currently in terms of how we organize things in the OpenStack community. In terms of technology, We will use the latest stuff, the Zool v3 and node pool from the OpenStack infrastructure. So we don't like reinvent the wheel and go do Jenkins kind of stuff, which is good and nice, but we moved out of Jenkins a while ago in the OpenStack infrastructure, and we need to have the same set of tools that is used in the OpenStack infrastructure. So, and then we are starting with the Open Telecom Cloud, Vex Host, Huawei Public Cloud, and Intel has some clouds as well. So those are the ones that we are going to start with, and then we are going to expand. Especially, it'll become very interesting when we do multi-cloud between these clouds and see what works and what doesn't work. Next one, please. Okay, so in terms of architecture, what we are trying to do is we know that we are using Gerrit, but not everybody is using Gerrit. So we are going to have github.com webhooks, especially for things like Gopher Cloud, and there's a whole set of people who build off of github.com. So we're going to support webhooks for them, and we have a portal that's the IP address. And essentially, what we are doing is we are running Apache, Zookeeper, Log Server, and StatsD as the services, and then we are using node pool to build the virtual machines that is needed to run the CI tests. And we use the Zool scheduler, executor, and the web interface and things like that as well. And then we run it against all the clouds that I mentioned before. Next one, please. So, I'm just going to show you some screenshots on how these things work. We have other sessions where you can actually try it out. If you go to the website, you can actually try it out yourself as well right now. But the idea is that you have a pull request in the GitHub repository, and then, for example, if you want to do a recheck, then what happens is the unit tests are run and the acceptance tests are run. The idea behind the unit test is you need to make sure that the unit tests at least work. And when you pass that, then you do the acceptance test. And the acceptance test is where you actually need an instance of an OpenStack to run against. So for example, this Gopher Cloud is a Go-based library, and it needs an OpenStack Keystone endpoint, and it needs the OpenStack services to actually try the API against, like starting a virtual machine, creating a network, and things like that. So the acceptance test is the one that, if you see there, it takes longer. It's 29 minutes versus the unit test, which is just 2 minutes. So it's more because it needs a real cloud, and you set up a real cloud, and then you run the test. Next one, please. So this is just like what we have in OpenStack infrastructure. We use the Zool web interface, so you can look at the tests when they are running, and you have like a slider that shows you how much time is left. Go ahead. So, and then you can actually look at the logs. This is nothing new here. Zool v3 supports scrolling logs, so we're just going to use that. Go ahead. And then when you run the tests, you can look at the run, pass, failure. And then here, the unit test finished, so you have the success green button. Next one, please. And then when you click on that, you can actually go look at the logs that were gathered when the unit test was run. Next one, please. And then when you open up the output file, output.txt.gz, you have the exact information that was collected as well. So the idea is that we have the OpenStack API. We're going to start with Gopher Cloud on the left, and then we are going to go on to all the others on the right over a period of time. And then in terms of the timeline, we're going to start with Terraform and Kubernetes. The reason for doing that is Gopher Cloud is a Go-based library that we want to test. And then the best way to test that is to test something that uses Gopher Cloud. So Terraform uses Gopher Cloud, Kubernetes uses Gopher Cloud. So we're going to test that to make sure that we are not just testing the library and its capabilities, but also its actual real-world usage as well. And then we are going to move to the right, and then we're going to start expanding the number of things that we test. So we're going to go on to Cloud Foundry, we're going to do Juju, SaltStack, InfraKit is from Docker team, and then ManageIQ and Nomad, etc. So next one, please. What are we asking from you? We are asking from you to get involved because this is the set of things that you are going to run in your environment, and you are going to face the same problems, and we are trying to solve these problems for you. So we need your help. We need access to your infrastructure, and Zool is a very good way of integrating multiple clouds. So if you give us an account and say, give us like 20 VMs or whatever, then we'll be able to use that infrastructure to run the same tests that we are running as well. So contribute to infrastructure, please. And we need help in terms of trying to figure out what needs to be tested, how it needs to be tested, and what combinations need to be tested, what OpenStack releases need to be tested, things like that. If you join us and if you help with your time and effort, then you get to have a say in what happens here. It doesn't have to be full-time employees. If you have some spare time, come and help us out. So, so mostly we are used to asking for development side information. Right now we are asking for, okay, you are an end user of the ecosystem. Now, from your point of view, what is important? That's what we would like to know. So please come and engage in this effort with us. And as a summary, we had a lot of experience with public clouds and private clouds, as well as NFVI. We have a really active upstream community as well as a downstream community with a lot of experience. And we have identified interoperability as one of the big things that, if we do it well, it'll be a big benefit to our customers as well as everybody in the community as well. So we would really like to see you help us with this effort. Thank you. Any questions we can ask, we can answer here. Okay. How about I ask something? Is there any tool or product or project that you would like us to test in Open Lab? Anyone that we haven't listed here already? No? Okay, looks like we have covered it. Thank you.
Thanks a lot. Thanks for your time.